In this video, you will learn how a device can be accessed. The Windows Device Manager can be accessed by the following steps. Step 1. Press the Windows logo key and the R key on your keyboard simultaneously. Step 2. Type D, E, V, M, G, M, T, period, M, S, C, and then press OK. In this video, you will see all of the steps needed to install and update device drivers. The Windows Device Manager can be accessed by the following steps. Step 1. Press the Windows logo key and the R key on your keyboard simultaneously. Step 2. Type D, E, V, M, G, M, T, period, M, S, C, and then press OK. Keeping your drivers updated provides many benefits. For instance, it protects your computer from vulnerabilities. In this video, you will see all the steps needed to reinstall device drivers. Launch the Device Manager. Right-click the device name and select Uninstall Device. Restart your computer. Windows will attempt to reinstall the driver.
In this video, let's learn about mounting and unmounting file systems. Mounting is a process used to ensure that the computer is correctly reading storage media. Mounting allows access. For a computer to interpret a file system's data properly, it must be mounted. Mounting is not always automatic. Many computer systems automatically mount and unmount file systems. In the above example, the last entry specifies that a Unix file system or UFS on the /dev /dsk /C0T3D0S7 slice will be automatically mounted on the /test mount point when the system boots. However, in Linux, this must often be done by the user. Similar to mounting in Linux systems, you will need to unmount any mounted file system before you disconnect the storage device on which the file system is hosted. To detach a mounted file system, use the umount command, followed by either the directory where it has been mounted, that is the mount point, or the device name. Unmounting removes access to the file system. If you don't unmount, you risk interrupting and therefore damaging any in-process file transfers. To eliminate that risk, unmount before disconnecting.
In this video, you will learn how to conduct common Windows tasks through Command Prompt. Windows Command Prompt's help files can help you use any command. Press the Windows logo key and the R key at the same time. Type CMD and then press OK. Let's understand the most difficult part, the syntax, and how to use the options. We'll use a very common command. dir displays a list of files and subdirectories contained in the current working directory. To compare it to the usual Windows view, imagine you opened a folder. The folder you opened, if you chose to do anything in it, would be the current working directory. First, let's demonstrate what happens when you type in the command. As you can see, it outputs a list of details about all the files and directories located in the current working directory, which is always spelled out in the prompt. If you read from left to right, you can see it has all the details, such as last modified data and time, if it is a directory, file size, if it is a file, and its name. Let's look at the help file to see what else we can do with this command. Type dir space /?. The help for the dir command appears as shown with various options. Now let's look at the syntax. Dir is the command. Brackets indicate that part of the syntax is optional. So, how to figure this out? Open square bracket, drive : close, square bracket, open square bracket, path close square, bracket, open square bracket, file name, close, square bracket. This part lets you specify the directory you want to investigate in the event that it is different from the current working directory. Open square bracket /A. Open square bracket, close square bracket attributes. Close square bracket lets you specify things like whether or not you want to see hidden files, system files, directories, and so forth. The open square bracket /B close square bracket, open square bracket /C close square bracket, and so forth options modify the way information is displayed. Open square bracket /O close square bracket has additional options you can specify by using the colon and the sub-options listed down in the options list. So, let's try an example of using the syntax guide. Suppose you want to see only the directories in the current working directory sorted alphabetically. Type dir space /A:\D. You can see that it only displays names of the directories in alphabetical order. If you type dir space /T:\A, then you can see the files and directories sorted according to the time they were last accessed. The /T command can be used with various switches such as C, A, or W to sort the file's directories based on time of creation, last access, and last written, respectively. You can combine these as long as you stick to the syntax, which specifies that each option must be preceded with a \, and sub-options must be preceded with a colon. For example, dir space /A:\D space /T:\A.
In this video, we will learn about a process control block. A process control block stores several pieces of information regarding the process to which it is associated. The process identifier, or process ID, is a unique numerical identifier for the process. Process states include waiting, running, ready, blocked, and halted. The program counter contains the address of the next instruction that is to be launched for the process. The Central Processing Unit, or CPU register, includes the accumulator, base, registers, and general-purpose registers. A stack pointer is required to be saved when the process is switched from one state to another to retain the current position of the process. Memory limit gives information about memory management, which may include the page tables, segment tables, and so on. The Open Files list consists of the list of files open for a process. Miscellaneous accounting and status data gives information about the amount of CPU used, time constraints, jobs, or process number. In this video, we will learn about different process states in an operating system. When a user opens a program, it enters main memory and the process enters ready state. The process is ready for launch. For example, the user opens a document in Word and the process enters ready state. When the user starts using a program, the process enters running state. The instructions given to the program are launched through the process. For example, if the user types and then saves the document, the Word process enters and exists in running state. When the user opens a second program, the first program enters waiting or block state. The second program enters ready state. For example, if the user opens an Excel file, the Word process enters waiting or block state and the Excel process enters ready state. When the user closes the program, the process enters terminated state. The process is completed and all related information is erased from the main memory. For example, when the user closes Word, Word enters terminated state. It remains in this state until all the files are saved and resources are released. After this, the Word process is removed from the main memory. A scheduler is a subprogram in an operating system that schedules the processor time for the active processes. The scheduler can move a process in ready state from main memory to secondary memory to manage the time for another process that enters the running state. The process that is moved to secondary memory enters the suspend ready state. This process will re-enter the ready state when the scheduler swaps it back to main memory. A scheduler may move a process from main memory to secondary memory if there is a space crunch in the main memory and the process is performing an input-output or I/O operation from the secondary memory. The process enters the suspend waiting or suspend block state in this case. The process will enter the suspend ready state when the I/O task is completed. When the process is swapped back to main memory from secondary memory, it enters the ready state. Let's take a look at the process lifecycle. As a process is launched, it crosses multiple states. Procedures or actions may vary in different operating systems or OSs. This is the first stage where a process is started and is waiting for a processor to be allocated. After the process has been allocated to a processor by OS, the process is ready to run as the processor runs its instructions. The process moves into the waiting state. The process may come into a ready state again, waiting for a user input. The process at this stage completes its task and then moves to the terminated state where it waits to be removed from main memory.
Let's learn about the types of networks. Here are three main types of networks, namely Local Area Network, also known as LAN, Metropolitan Area Network, also known as MAN, and Wide Area Network, also known as WAN. A local area network, or LAN, is a network that connects devices within the same building and are usually private networks. For example, a home Wi-Fi or an office enterprise network can be a LAN network. A metropolitan area network, or MAN, is also called a campus area network, or CAN. It is a network of networks, is limited to a campus, and can be extended to an entire town or city. For example, a company's branch offices across a city are connected to the company's central server located at a data center at the company's main office. These networks are created to keep the systems of the organization safe while company information is accessed and exchanged among each other from the organization's data center. Another example can be a university network. The last category is a wide area network, or WAN. This is a network of computers and spreads beyond the boundaries of a building, city, or even a country. A classic example is the Internet or World Wide Web. It is the worldwide research and defense network that shares information across the globe or even with space stations away from the Earth while keeping the information secured from people who are neither a part of the network nor authorized to access the network resources. Let's learn about the types of networks. There are 4 common types of computer networks. In this video, we will describe them in order of their size, from smallest to largest, namely Personal Area Network, also known as PAN, Local Area Network, also known as LAN, Metropolitan Area Network, also known as MAN, and Wide Area Network, also known as WAN. PAN, or Personal Area Network, is a very small network. Bluetooth connections are an example of a PAN. It connects personal devices to each other, like computers and printers, laptops and phones, even headphones. A PAN is much smaller than the next network type, the LAN. Bluetooth is a technology of a PAN, but it could also be wired by USB or FireWire and wireless ultra-wideband, or IRDA. Local Area Network, or LAN, is the most common. It connects computers across short distances, such as within a building. A LAN is privately owned and with less traffic than a MAN or WAN. It has less network traffic congestion. As a result, LANs are relatively high speed. MAN is a metropolitan-sized network. Many cities use a MAN to provide internet access to their residents. These can be publicly or privately owned. They have relatively more traffic than a LAN, but not as much as a WAN. This results in an average transmission speed. The largest size network is a WAN, or Wide Area Network. These are the networks that allow us to communicate around the world. The Internet is an example of a WAN. With so many computers connected, network traffic congestion is relatively high, and a WAN is not as fast as the smaller-sized networks.
Let's learn about the OSI model. The Open Systems Interconnection, or OSI model, is a conceptual framework that describes the functions of a networking system and provides a visual representation of how networks communicate with each other by sending and receiving data. The OSI model divides network communication into 7 layers, with each layer performing a specific task in the process of sending and receiving data. These layers illustrate the inner workings of a networking system. Understanding the OSI model is beneficial in troubleshooting network problems, as it allows you to isolate the source of an error and narrow the issues down to a specific layer of the model. This short video will discuss Dynamic Host Configuration Protocol, or DHCP. What is DHCP? It is a standard network protocol that allows a server to automatically assign IP addresses to computers and devices on a network. Computers are required to have an IP address to communicate over a network. A DHCP also generates a central database to keep track of devices that have already been connected to a network. This ensures that computers and other devices are not accidentally given the same IP address.
In this video, we will learn about what an optical fiber is, when it is used, and how it works. Fiber optics, or optical fiber, is a cable technology that transmits data in the form of light pulses along a plastic strand or fiber. This technology is used to transmit data at an extremely high speed over a long distance. Optical fiber technology is used in several fields, such as the Internet, telephonic communication, cable TV, and medical science. Some of the components that use this technology include Ethernet switches, routers, firewalls, network interface cards, and fiber media converters. Optical fibers use optical transmission, the process of converting electrical signals to optical signals and vice versa, to transmit data. Before transmission, the data is converted from electrical signals to light pulses. Once the data reaches the intended endpoint, a receiver, the light pulses are converted back to electrical signals. The device that converts electrical signals to light pulses with a specific wavelength and vice versa is called an optical transceiver. Next, in this module, we will explore the various types of optical transceivers. In this video, you will learn about how to correctly handle fiber and copper cables. Careful handling of fiber and copper cables is critical to data center operations. There are 5 types of damage that can be done to fiber and copper cables by physical damage, physical tension, corrosion, electromagnetic loss, and incorrect storage. Physical damage includes tightly wrapped cables and can be prevented by loosely wrapping cables individually. Physical tension occurs when a patch connector or cable is too short. In this case, ensure that your cable is the correct length. For metallic copper cables, there is a risk of cables oxidizing, known as corrosion, so cut a small portion of the outer jacket instead of individual cables. Many data centers might have two kinds of cables, which can create electromagnetic loss. When this happens, install copper cables in a separate conduit away from other cables. And lastly, cables often become tangled when stored incorrectly, so it's a best practice to store cables in an organized manner using Velcro. Zip ties can be used to manage copper cables only. Do not use zip ties to handle fiber cable.
In this video, let's learn about data encapsulation. Data encapsulation is a 5-step process that starts in the application layer of the Transmission Control Protocol/Internet Protocol, or TCP/IP model. Application layer takes the data from data streams, encapsulates them by adding the protocol details, and forwards them to the transport layer. The transport layer takes the data from the application layer and breaks the data into segments, then encapsulates each segment by adding a header with sequence information. Next, data segments from the transport layer come to the network layer, where they are encapsulated with an additional header containing routing information, such as source information and the IP address needed to deliver the data. This encapsulated data is now called a data packet. The data link layer takes data packets and encapsulates them with a header and trailer. The header contains the procedure to deliver the data to the respective receiving device, and the trailer contains error detection mechanisms. The encapsulated data at this stage is called a data frame. Finally, the physical layer takes the data frames from the data link layer and converts them into the right format needed to be transmitted over a network. For example, converting data into radio signals. This is how data is transmitted safely from sender to receiver through networks.
In this video, you will learn about the function of a Network Address Translation, or NAT. A NAT allows devices connected in a private network to use the same public Internet protocol, that is, an IP address. Private networks can be as small as a home or as large as an entire office building. Access to a single public IP address can be shared using a router, gateway server, or proxy server. Internet Protocol version 4, or IPv4, is limited to 4,294,967,296 unique addresses, 3.3 billion of which are available in the public domain. In 2019, some households required more than 20 IP addresses due to the various devices connected to the Internet. Examples could be smart TVs, Amazon Echo, computers, smartphones, and the like. This makes it impossible for a unique public IPv4 address to be assigned to every device connected to the Internet.